Okay, welcome. Thank you all for being so punctual. Happy to have you all here. We're going to be doing some quant reasoning exercises in regards to the GMAT. The topics will be on word problems and percents and interest. During the workshop, please let's have our microphones muted. You're going to notice on the top left an ID, a question ID. If you have any questions regarding any specific exercise, just take a note of that question ID and send me a message. I'll be happy to help you out. All right, so we're going to start off with a bit about me. Promise it's going to be short. So I've been coaching the GMAT for over 5 years, coached more than 250 MBA hopefuls. I sourced, hired, and led a GMAT department at a company that sold admissions consulting and GMAT preparation. I'm a full-time coach for GMAT and admissions. I have 35 plus 5-star reviews on Leland alone. I did my MBA at Booth. I was enrolled and admitted with a merit-based scholarship. At Booth, I was part of the admissions team for Argentina specifically. I'm also really good at helping people get into top MBA schools in the US or Europe. Before going to Booth, I had 4 consulting offers through pre-MBA recruiting. I signed with BCG and was a mentor at Booth Consulting Club. Okay, so let's talk about this specific workshop. You're going to be given 3 to 5 minutes to do each exercise, and then I will explain how to approach the exercise in my point of view in the optimal fashion. All right, let's get started. Okay, you have 4 minutes. All right, time is up. Hopefully you had enough time to complete this exercise. If not, that's fine. Let's just stop moving our pen or pencil and let's absorb this explanation. Great, so we're being asked how many kangaroos were there at the start of 2021? Now, the good thing about the GMAT is that it's a multiple choice test. The right answer is in front of you. You only have to choose it. So I like to leverage this fact by assigning a variable x to the answer choices. By doing so, you're going to see how we can visualize how we approach this problem a lot more easy. So once again, 2021 is equal to x. I also like to be very organized, right? So we're given some knowledge of what the year end would be in reference to the year start. So if we make a table for 2021 to 2023 inclusive, we're going to be able to be very organized when we do our operations. So we know that there was a constant annual growth rate of 1/3, which means that the year end is equal to year start plus 1/3 year start. Essentially, the year end is 4/3 year start. Now, if we were to look at 2021 and we use X as the year start, 2021 has 4/3 X. 2022, same logic. It's 4/3 the start of 2022. Now the start of 2022 is the same as the end of the previous year, in this case 2021. So what we can do is input the value for end of 2021 into year end 2022. So we have 4/3 of 4/3 X, which gives us 4/3 squared X. We continue with the same logic for 2023, and we're given that 4/3 2023 year start. So we can input the value for the end of 2022 into 2023, and we have 4/3 times 4/3 squared times X, which gives us 4/3 cubed X. Now going back to the exercise, we're told that the year end for 2023 is equivalent to 64,000 kangaroos. Therefore, we know that 64,000 must equal 4/3 cubed times X. And now we can solve for X. So we can distribute the power to both sides of the fraction, and we have 4 cubed divided by 3 cubed times X is equivalent to 64,000. We can pass the fraction to the other side by flipping it. So we have 64,000 times 3 cubed divided by 4 cubed. Now we don't have a calculator for the QR portion of the GMAT. So we have to be very efficient of how we approach arithmetic. We know that 64,000 is 64 times 1,000. 64 is 4 cubed. Now we're going to be able to cancel out the 4 cubed with this 4 cubed, and we're left with 1,000 times 3 cubed, which gives us 1,000 times 27, and that X is equal to 27,000, and that is our answer, C. So how I approach quant is to be very organized, help yourself visualize exercise as much as possible. We did that by assigning a variable to the answer choices. Great. Let's go on to the next exercise. You have 5 minutes for this one. All right, time is up. Definitely, this problem is a bit more complex than the previous. The most important thing is that you try. You're going to get better. Let's see how we can approach this exercise. So let's work with what we know. We know that z must be less than 50, yet greater than 30. This is something that we must respect. So we're told that the students sit at tables with 6 students at each table, except for one other table. And we're being asked that table that has less than 6 students will have how many students? So let's visualize the cafeteria, right? So we can say that z equals some amount of tables that contain 6 students each. So we could say that z equals 6, x amount of other tables, where x must be an integer. You cannot have a third or half a table, plus one other table that we don't know the value in regards to how many students are sitting at that table. We can assign a value to the amount of students sitting at that other table. So we're being asked b equals what? Now, we know that z equals b plus 6 times however many x amount of tables. So z equals b plus 6x. Therefore, we know that b equals z minus 6x. In essence, b is what's left over after z is subtracted by a multiple of 6. Therefore, we can visualize the question as the total amount of students at z divided by 6 has what remainder, because that remainder will essentially be the amount of students that must sit at this table. All right, so let's look at this portion of the problem. During lunch, the students sometimes sit at tables with 5 students at one table and 4 members at each of the other tables. Members being students, of course. So we can visualize the cafeteria, and we have tables of 4 students each, and we don't know that amount. We can say that it's y other tables, plus a single table with 5 students. Therefore, we know that z must equal 5 plus 4 times y. Therefore, z minus 5 equals 4y. And we also know that z minus 5 divided by 4 equals y. We know that y is an integer. So we know that z minus 5 divided by 4 equals an integer. And that was the logic behind why isolating y. Because when we isolate y, we're given another hint of what z must be. So z must be within this range, and also z minus 5 divided by 4 must be an integer. Great. Now let's look at this portion. On other days, they sit at tables with 6 students at one table, 4 students sit at another table, and 3 students sit at each of the other tables. So this is the cafeteria. Z is equal to tables of 3 students each, W amount, plus a table of 6 students and a single table of 4 students. So Z equals 6 plus 4 plus 3 times W. Essentially, Z equals 10 plus 3 times W. Z minus 10 equals 3 times W, and therefore Z minus 10 divided by 3 equals W, which is an integer. So we're given another piece of information in regards to what Z must be. Z minus 10 divided by 3 must be an integer. Great, so what do we do with this information? We want to find values of Z that satisfy both of these constraints, as well as the inequality or the range. All right, let's look at the first constraint. Z minus 5 divided by 4 must be an integer. We keep into account that Z must be between these two values. And since we're trying to find values for Z minus 5, we can manipulate the inequality, and we're left with 45 must be greater than Z minus 5, which must be greater than 25. We're just subtracting 5 from each term. Now let's think of possible values of Z minus 5, and therefore what Z must be. For example, Z minus 5 could be 28, because 28 is within this range and is a multiple of 4. Therefore, Z must be 33. We add 5. Another possible value for Z minus 5 is 32, because 32 is within this range and also respects the constraint. And therefore, Z must be 37. Z minus 5 could be 36. Same logic. It's a multiple of 4 within this range. So we add 5, Z becomes 41. Z minus 5 could be 40. It's a multiple of 4 within this range. Z could be 45. Z minus 5 could be 44. And Z must be 49. Now, with this in mind, what we can do is, when looking at the second constraint right here, we can see which values of Z that respect the first constraint also respect the second constraint. So if we have Z is 33, then Z minus 10 is 23. But 23 is not respecting constraint 2. What about when Z is 37? Z minus 10 becomes 27, which does respect the second constraint. So here we have another value for Z that's respecting constraint 1 and constraint 2. When we look at 41, Z minus 10 becomes 31, which is not respecting constraint 2. When Z is 45, we have Z minus 10, 35, doesn't respect constraint 2. When we have 49, Z minus 10 becomes 39, which does respect the second constraint. So we have two valid values for Z that respect constraint 1 and constraint 2. Now, for the purpose of this question, we're not really focusing on the value of Z necessarily. We are looking for the remainder when Z is divided by 6. So let's look at Z1. Z1 divided by 6 is 37 divided by 6, which gives us 6 1/6. So 1 is a remainder, which means that one student must sit at the table that has less than 6 students. Let's look at Z2, just to corroborate and make sure that we're valid and verify our answer. Z2 over 6 is 49 over 6, which is 8 with a remainder of 1. There we go. That's our answer. Both Z1 and Z2 have a remainder of 1. Great. Let's go on to the next exercise. You have 4.5 minutes. right, time is up. Hope you had fun doing this exercise. This is a must be true question. Now, when it's must be true, if you can disprove an item 1, 2, or 3, if you can disprove it once, you can eliminate that item. And that's going to be our objective throughout this explanation. Okay, so I really like to be organized and visualize my quant reasoning exercises. So this is essentially laying out a framework in which we're going to be able to choose valid sets of values for Josh, Victor, and Robert that respect the constraints. The constraints are Josh is equal to 3 times the age of Victor. Robert is 4 years older than Victor. And Victor, therefore, must be 4 years younger than Robert. Now, I cannot stress enough how important it is just to write out what you know. And don't worry about what you don't know. Start with what you know and how can you be as organized as possible. So we're translating English into math. Great. So essentially, Jan 10th, 2025 to Jan 10th, 2030 is equal to 5 years. So whatever value we have for J here, we must add 5 for 2030. Great. So let's choose a valid set of values for J, V, and R. The easiest way to do this is to just put a value for one of these actors. Let's say Victor is 3. Therefore, J must be 9 and R must be 7. Great, now we can input the values for 2030. V plus 5 is 8, J plus 5 is 14, and R plus 5 is 12. So this is a valid set of values for Josh's, Victor's, and Robert's age on Jan 10th, 2030. Now we look at each item and we see if it's true or not. Item 1, Victor is 4 years younger than Robert. That is true. Item 2, Josh is 3 times as old as Victor. This is false because 14 is not equal to 3 times 8. So we can eliminate item 2. And therefore we can eliminate as well answer choices B, D, and E. Item 3, Josh is older than Robert. This is true. So we were able to eliminate 3 answer choices using this set of values. Let's repeat the process until we can eliminate 4 answer choices. So let's say V is equal to 1. Therefore, J is equal to 3 and R is equal to 5. Great, in 2030, V would be equal to 6, J would be equal to 8, and R would be equal to 10. And now we look at item 1. Victor is 4 years younger than Robert. That is definitely true. Item 3, Josh is older than Robert. Well, in this case, in 2030, Josh will not be older than Robert. So this is false. We can eliminate item 3 and therefore answer choice C. So after process of elimination, A is the correct answer choice. Now, there might be more direct or quick ways to approach this problem, but I always like to, by default, make these matrices, make these frameworks, be organized. If you do that, you can apply this way of approaching exercises to a ton of GMAT QR exercises. So no, it's not the most efficient way to solve this particular problem, but you can extrapolate this logic and manner of working to almost any QR problem. Great, let's go on to the next exercise. You have 5 minutes. All right, time is up. Fun exercise, right? Practicing for a race car competition. I do it all. Josh is in every single episode. Okay, so let's draw out what's going on. We have an ovular track. We have Josh and Emiliano. These are the cars. Josh is the orange and Emiliano the purple. They both start driving from the starting point right here. Of course, I'm faster. I'm a really good race car driver. Josh's time per lap is 35 seconds. You can also consider this the rate. And Emiliano is slower than Josh. He takes 45 seconds per lap. We're just writing out what we know. Now, we're trying to see the point in time in which Josh and Emiliano will be both at the starting point. What's the minimum time? Because when I have the minimum time, I can then calculate how many laps Josh did in that amount of time. Let's do that. So we know that Josh will be at the starting point every 35 seconds, which means that every multiple of 35 seconds, Josh is at the starting point. So at second 35, second 70, second 105, Josh will be at the starting point. Emiliano, on the other hand, will be at the starting point every 45 seconds. So once again, at every multiple of 45 seconds, Emiliano is at the starting point. So second 45, second 90, second 135, Emiliano will be at the starting point. Of course, we're looking for the time in which they're both at the starting point. So we want to see common multiples of Josh's time per lap and Emiliano's time per lap. At all the common multiples, Josh and Emiliano will be at the starting point. But our question asks us to find the first time after commencing the practice. Therefore, we're looking for the least common multiple of these two times per lap or respective rates. We're looking for the least common multiple of 35 and 45. The least common multiple is the product of all the primes to the highest exponent. What does this mean? We'll do it. 35 prime factorized is 5 times 7, and 45 prime factorized is 3 squared times 5. So all the primes would be 3, 5, and 7, and we list the highest exponent for each respective prime. So the least common multiple would be 3 squared times 5 times 7, which gives us 315. Now this value is the least common multiple. And in reference to our question, this means that at second 315, it will be the first time that Josh and Emiliano are both at the starting point. We're looking for how many laps did Josh do during this time. So we must divide 315 by Josh's time per lap or his respective rate. So we have 315 divided by 35, which gives us 9. And that is our answer. Josh did 9 more laps than Emiliano before the first time they meet at the starting point. Great, let's go on to the next exercise. You have 4.5 minutes. All right, time is up. You give a little bit more than 4.5 minutes. It is a complex exercise. the most important thing is that you attempt it, you try. You spend this time thinking about what you do know, putting it onto the paper. You will be surprised what you can get to and achieve when you just think about what you do know. Super true for the GMAT. All right, let's look at this problem. It's not me cutting the pizza, it's Mario. Much better Italian name than Josh, right? Okay, so we know that Mario is the master pizza maker. He's an expert at cutting supersized rectangular pizzas. So this is our pizza. Our rectangular pizza is right here. Now, we know that n equals the number of people. And we can assign a variable to the slice, x, the amount of slices that Mario must perform. And I want to understand, get myself immersed into this exercise. So I want to ask myself, okay, when n equals 3, how many slices does Mario have to make? Well, he has to cut it once. 1 over n becomes 1/3. And a second time. We will have 3 portions of 1/3 each. So when we have 3 people eating this huge pizza, Mario must slice the pizza 2 times. Great. So what happens when n equals 4? So Mario must cut the pizza once to create a 1/4 slice right here. Another time to create another portion of 1/4. And a third time that creates 2 portions of 1/4. So when we have a pizza for 4 people, Mario must slice the pizza 3 times. And what we can deduce from this is that the number of slices or cuts that Mario must perform is equal to n minus 1. Once again, we came to this conclusion just by drawing out the problem, trying to immerse ourselves into the exercise by thinking, what happens if n equals this amount of people? And you start off with easy examples. N equals 3, n equals 4. Great, so we know that the amount of cuts or slices that Mario must perform is equal to n minus 1. And we're going to do the same logic with y. Y is equal to the time interval between each slice that Mario performs. And we know that the time it takes to slice the pizza is twice the time between each slice. So x time is equal to 2 y time, or y time is equal to 1/2 x time. So let's go back to our example of when n equals 3, and thus x must equal 2. What we want to do is see how many time intervals are there between each cut or slice that Mario performs. So between the first and the second slice, there's 1 time interval. So when n equals 3, x equals 2, and y equals 1. Let's see the same example or same logic when n equals 4. When there are 4 people eating the pizza, Mario must perform 3 slices or cuts into the pizza. And therefore, we have 1 time interval between the first and the second cut that Mario performs, and a second time interval between the second and the third cut that Mario performs. Therefore, we have the amount of y equals 2. And what we can conclude is that the number of time intervals, or y, is equal to the number of slices minus 1. So amount of y equals amount of x minus 1. Great. We have all the information we need to solve this problem now. Very clear. So essentially, when Mario slices a pizza for 8 people, the time lapse between the beginning of the first slice and the end of the last slice is 20 seconds. So we know that n equals 8, therefore x equals 7, and y must equal 6. And we know all of this is essentially equal to 20. The total time is equivalent to the total time to perform the slices plus the total time of the time intervals. So we have 7 slices, so 7 times the time it takes for x, plus 6 time intervals, so 6 times the time it takes for each interval. We know that 20 seconds is the total time. And we know that the amount of y, or y time, is equal to 1/2 x time. So we have 6 times 1/2 x time. So we have 20 seconds is equivalent to 7x time plus 3x time. 20 seconds is equal to 10x time. X time is equal to 2 seconds. If x time is equal to 2 seconds, y must equal to 1 second. So the real question being asked is, what happens when we have 12 people eating the pizza? Great, so the amount of slices that Mario must perform is equal to 11. The amount of time intervals between each slice is equal to 10. And we have the time for each slice and the time interval between slices. So the total time is equal to 11 times x time plus 10 times y time. We input the values for x time and y time respectively, and we have 11 times 2 seconds plus 10 times 1 second, or 22 seconds plus 10 seconds, gives us a total time of 32 seconds. Yes, indeed, Mario can cut a supersized rectangular pizza for 12 people in a total of 32 seconds. True master. Okay, fun one, right?
So Josh, just a quick question.
Do you mind if we leave the questions after the workshop, please?
Sure.
Thank you. You have an ID right here, 7009 GWP. Please take note of that. More than happy to help you out via message on Leland. All right, let's go on to the next question. You have 4.5 minutes.
I think you stopped sharing your screen.
Oh. Okay, thank you for letting me know. Does anyone else see that happening?
Yeah, I also don't see it.
Okay, thank you. Is it good now?
Yeah.
Awesome. Thank you for the heads up. Okay, go for it, please. All right, time is up. Hope you had enough time to finish this exercise. If not, attempting it more than fine. Let's see how we can approach this problem. So obviously we are now at the percent and interest part of this workshop. So I want to highlight, as per the question, it states, during Black Friday, approximately what percent of the selling price in market X is the selling price of product T in market Y? So we can think of this as Y's discount price in terms of, or as a proportion of, X discount price. Somewhat of a ratio, right? We want to translate that fraction into a percentage decimal notation. So Y's discount price as a proportion of X discount price. We can visualize this as Y discount, the D denotes discount, divided by X discount. XD denotes X discount. And we want to put this into a percentage, of course, by subtracting 1 from that. So we're being asked Y discount over X discount equals what in terms of percentage? So we know that market X provides a 25% discount. So XD equals original X minus 25 over 100 original X. The O denotes original. Thus, X discount is 3/4 original X. Great. We also know that market Y provides a 40% discount. So we know that Y discount is equal to Y original minus 40 over 100 Y original. Therefore, Y discount is equivalent to 3/5 Y original. Not doing anything too fancy. We're just expressing what we know from the word problem into math. We're putting these percentages into fractions because on the GMAT QR section, you cannot use a calculator, and therefore doing operations with fractions are a lot easier than with decimals. So we know that the list price of product T is 35% higher in market Y. 35% higher in regards to X. So we know that original Y is equal to original X plus 35 over 100 X original, which gives us Y original is equivalent to 135 divided by 100 X original. Now we can input a smart valid value for X. And what is a smart valid value? Well, in this case, a valid value would be anything greater than or equal to 0.01, because a price cannot be negative, of course. And a smart valid value would be a value greater than 0.01 of a dollar, and that's easy for us to do operations with. So 100 is a pretty good value to choose. So if XO or X original is 100, then Y original would be 135. And now we can calculate both y discount and x discount. The reason why we can input a value for these variables is that everything will be in proportion. If I were to have chosen x original as 200, then y original would have been 270. So everything will be in proportion. We're not looking for a finite value. We're looking for proportions in relation to percentages. Great. So once again, we have x original 100, y original 135. So we go here and we say that x original 100, we input it and we get x discount is 75. Now we do the same process for y discount. Y discount is 3/5 y original. So we have 3/5 times 135. 135 is 5 times 27. We can cancel out the 5s. Y discount is 3 times 27, which is 81. So we have the values for x discount and y discount. Going back to the main question, we have y discount divided by x discount. We're given 81 over 75. I want to highlight the word approximately in the question. This allows you to round in an intelligent fashion. So we have 80 over 75, which gives us 16 over 15. So y discount is approximately 16 over 15 x discount. Which could be also visualized as x discount plus 1 over 15x discount. And this is how much more y discount is in comparison to x discount. T is 1/15 times more expensive at y than at x. So 1 over 15 is less than 1/10, yet greater than 1/20. We know that 1/10 is 10% and 1/20 is 5%. So 1 over 15 must be within these two values, and therefore the answer must be C. Great. Let's go on to our next exercise. You have, I'll give you 5.5 minutes for this. All right, time is up. Yeah, this exercise requires a lot of arithmetic, a lot of calculations. I hope that you used fractions instead of decimals. All right, so I want to highlight, given from the words in the exercise, what was the shop owner's approximate profit or loss as a percent of the shop owner's initial cost for the 40 turbines? So let's highlight profit or loss as a percent of the shop owner's initial cost. We're looking for the profit or loss in proportion to or fraction of the total cost. And then we will translate that proportion into percentage. So profit or loss in proportion of the total cost is equivalent to total revenue minus total cost divided by total cost. Essentially, this will give us total profit or total loss divided by total cost, which gives us total profit. This pi represents profit divided by total cost equals what percentage? That is our question. So we are translating English into math. Great. Now, let's highlight that each Model T is sold for $300 each, which represents a 20% markup over the shop owner's initial cost for each turbine. So the unitary price is 300, which equals the cost plus 20% of the cost. When we're talking about a 20% markup for the GMAT, it is implicit that the markup is in relation to the cost, which makes total sense. If I say I made a 10% profit, what is that in relation to? My cost. So 300 equals cost plus 20% of cost, which is cost plus 20 over 100 cost, 1/5 cost. We have 300 is equal to 6/5 cost. We pass the fraction over here by flipping it, we can multiply. 300 is 6 times 5. We can cancel out the 6 on bottom and on top. We have 50 times 5 is equal to the cost, or that 250 is equal to the unitary cost. We have 300 is equal to the price, and therefore for every unit that we sell, we have a 50 profit. Let's talk about the refund. So 8 were never sold and were returned to the manufacturer for a refund of 60% of the shop owner's initial cost. So the refund is 60% of the cost, 60 over 100, 6 over 10, or 3 over 5. So our refund is equal to 3 over 5 the cost. The unitary cost is 250. 250 is 5 times 50. We cancel out the 5 on top and on bottom. Refund is equal to 3 times 50, or 150. So the refund that we get for each unit that we return minus the cost will give us the profit for each returned unit. And it's profit because it's a negative profit or a loss. So we have 150 minus 250, and thus for every unit we return, we have a negative profit or a loss of $100. Great. So we're being asked what's approximate profit or loss as a percent of the shop owner's initial cost for the 40 turbines. So the total profit is equal to the profit we get from each unit sold plus the profit or loss that we incur for each unit we return. So we know that the amount of units we return is 8, and therefore the amount we sell is 32. Therefore, the profit that we get from each unit sold is 32 units times 50 per unit, which is $1,600. And in terms of how much loss we incur due to the units returned, well, we have 8 units returned times minus 100 gives us minus 800. So our total profit for the 40 turbines is 800. Of course, we're not finished. We have to look into the cost. So the cost is basically the total amount of units times the unitary cost. So we have 40 units. A unitary cost of 250 gives us a total cost of 10,000. So our total profit is 800 divided by the total cost of 10,000. We cancel out 2 zeros on top and bottom. 8 over 100 represents an 8% profit. And that is our answer, C. All right, let's go on to the next exercise. Go for it. You have 4.5 minutes. All right, time is up. Turkey. It's been a while since Thanksgiving. I was inspired by the turkey that night. All right, let's see how we can approach this problem. I like to use what I call the tic-tac-toe matrix to solve two group overlapping sets. Now let's see how we can apply this to solve our question extremely easily. So we have two groups, people that ate turkey and people that did not eat turkey. We had people that put sauce on the turkey and people that did not put sauce on turkey. We have to put some foundation to our tic-tac-toe. We put this with sigma. Sigma denotes total. And in this quadrant, where turkey intersects with sauce, represents turkey and sauce. The quadrant right here is only turkey, no sauce. If we add these two quadrants, we have the total of people that ate turkey. This quadrant, which is the intersection of not turkey and sauce, represents only sauce. And this quadrant right here represents neither turkey nor sauce. When we add these two quadrants, we have the total of not turkey. When we add these two quadrants, we have the total of sauce. When we add these two quadrants, we have the total for not sauce. And this field right here represents the total of the total amount of people. All right, let's see how we can apply it to this question. We're being asked, what percent of the total amount of diners ate turkey? We're looking for the proportion of turkey in relation to the total diners. So this is translating English into math. Now we can say that the total amount of diners is equal to Z. And therefore, we know that since 20% of the diners ate turkey and placed sauce on top of the turkey, this quadrant is equivalent to 1/5 Z, turkey and sauce. 60% of those that ate turkey did not put sauce on top. Now, those that ate turkey is in relation to total turkey. We can say that total turkey is X. So we know that 60% of X, or 3/5 of X, is turkey and not sauce. We know that when we add these two quadrants together, it must equal total turkey. So 1/5 Z plus 3/5 X must equal X. And therefore, this must equal 2/5 X. Remember, this plus this equals X. This 3/5 X. This 2/5 X. And also 1/5 Z. So we know that turkey and sauce, sorry about that, is 1/5 Z and 2/5 X. So 1/5 Z must equal 2/5 X. Given that, give me 1 second, please. course. All right, so does anyone have an answer for this actually? Mic's open.
I put 50%.
Great, because 1/2 z must equal x. Because if 2/5 x equals 1/5 x, that means that z must equal 2x. And so x is 50%. And that is our answer. Thank you for that. Cool. Awesome. So that concludes the exercise portion of our workshop. Please, if you like this, write a review. It will motivate me to create more workshops. I have another workshop next Saturday at the same time. Going to be equally as helpful, if not more. Thank you so much.